Hello and welcome to class 25 of my course on physics 2. It has been a long journey and now we'll be entering into the last topic of our entire course, that is the electromagnetic theory. It's last but not the least, and it keeps many interesting topics. Herein, the fundamentals of entire electromagnetic communication, how signal goes from one place to another, that story to be unfolded to you. Basic theoretical background of that you'll be coming to know. And this theory was long back proposed by Maxwell. So Maxwell's idea you'll be getting. Now Maxwell's first idea, or we call it Maxwell's, he has got four equations. Maxwell first equation is about electrostatics, second equation is about magnetostatics, third equation is about electromagnetics, and fourth equation is also is electromagnetic theory. That is, third equation tells that a change of magnetic field can produce electric field, and fourth equation tells us change of electric field, a time varying electric field can produce magnetic field. So on the basis of these four equations of Maxwell, the electron wave equation was formed, and how electromagnetic wave passes through a medium, that description was made. So basically, as you can see here, that those four equations of Maxwell will be automatically developed. And we'll begin with electrostatics. Now, this is, as you can see here, I'll begin with electrostatics. This is me, obviously. Now, the entire study of electrostatics, okay, or magnetostatics, or electromagnetic theory, or as a matter of fact, for the entire development of Maxwellian idea, Maxwell's equation, okay, are done. This entire study is made through the ideas of vectors, vector calculus. Okay, the differential part of the vector calculus and the integral part of the vector calculus. So basic vector analysis idea you might be having from your earlier life, earlier courses. You studied in mechanical courses, mathematics courses, even in the 10+2 standard also a lot of vectors are now being taught. So those ideas are the basic weapon to learn electromagnetic theory. You have to learn everything with the language of vectors. Just like in quantum mechanics, we learned about state vectors. So these are, okay, and those with state vector, we represented a function. And before that, what I did, I have told you the elementary of what is called state vector, etc., etc. So after giving that theoretical background, I actually did everything. So here also, to learn electromagnetic theory, basics of vector calculus need to be known. So as I did in my quantum computation course also, I first illustrated the fundamentals of state vectors, vector space, etc. Here also I'll first open up or I'll discuss the fundamentals of vector calculus. Okay, so I'll do that. So everything is done through vectors, as you can see. So our course will include basic concepts. So first sub-module is the basics of vector calculus. It includes the physical meaning of the sum of the vector calculus operation. You know the differentiation means change. If you take change of a scalar function, that is called gradient, and change of a vector function can be two types. One is divergence, another is curl. So these concepts are applied all in electrostatic, magnetostatics, electromagnetism, and electromagnetic theory. Now I'll begin my discussion obviously one by one. First I will describe what is called gradient, what is divergence, and what is curl. Now we take gradient of a scalar function, that is change of a scalar function is called gradient. Change, and gradient is a vector quantity. Divergence of a vector quantity is taken for a vector. And curl is also taken for a vector. Now what does it mean physically? Because in mathematics courses you might have learned how to calculate it, how to do it. But my job is to tell you the physics of it, physical meaning of it, because to me, gradient of something, gradient of a vector, maybe electric field or magnetic field, whatever it may be, it has got some meaning to me. Each operation, each of this calculation, each of this step is going to give you some learning, some physical meaning is expected to open up, okay, from this gradient operation, okay. So whatever you do, maybe you'll be taking gradient of a function, maybe you'll be taking divergence of a vector, maybe you'll be taking curl of a vector. Now taking divergence means you are calculating flow. Taking curl means you are calculating rotation, vorticity. So basically, so all this mathematical operation has got some meaning. So those physical meaning will be trying to highlight so that you can connect that with your own classes of electrostatics. So now what is the physical meaning of the gradient? Gradient is taken for a scalar function. For example, temperature. You can see a bulb is there. Just imagine a bulb is there and it is on. So it is it will not just emit light, it also emits heat. So if you are remaining very close to the bulb, it is higher temperature, and as you go away from the bulb, it is at a lower temperature. Then we say there is a gradient in temperature, and gradient is a scalar because it does not depend on the direction. If the bulb is there for one direction, what you witness for all possible direction you witness the same thing. Okay, you see all possible direction, you experience this change. Okay, so it is direction independent, isotropic, as a matter of fact. All directions are similar way for the particular bulb. So change is there, and it is direction independent. So it is a change of a temperature. It is a scalar quantity, does not depend on the direction. So change of a scalar is calculated through gradient operation. Okay, or suppose we are heating a rod, the portion which is close to that hotter region, it will be more hot, and the portion which is at a cooler region, which is away from it, less hot. Okay, actually, then a temperature gradient is created. Okay, the left, according to my drawing, the one the end left side which is more close to the which is being hot, so that will be at a higher temperature, and the opposite other corner will be at a lower temperature. So there is a temperature gradient. Okay, and this, because of this temperature gradient, heat conduction takes place. Okay, it's a very important idea. Or you see, look at this picture. Okay, sun is, you see, this is how daylight changes across the day. Okay, sun setting to sun rising, or sun rising to sun setting, whatever you say, you see something is changing. It is the gradient of the daylight. Okay, daylight intensity is changing. Okay, so gradient means change, and irrespective of the direction of the change. Okay, this change will be witnessed from any place. Okay, anywhere. It is not direction independent. Okay, this is the form of the gradient operator. Del x del. It's a, you take gradient of a scalar. So u is the scalar quantity, and del x I cap, del y j cap, del z k cap are the is a gradient operator. Now operate u on it. If u is c dot r, that vector. So suppose c is c1x, c2y, c3z. Okay, and if you take a, and you see, you can do it like this. CR, C is the magnitude. Okay, you can see there, you can calculate it. Okay, so gradient operator is I del L x I del L y j del L z k. You take it, operate it on a scalar u. Now here comes a very important concept that is called directional derivative. Okay, now let me show you by hand. Okay, so that you understand how it is calculated. Just give me 2 minutes. Scalar quantity. Okay, u, which is C1x plus C2y plus C3z. Now I wish to take gradient of u. Operator del x I del y j del z k of this much C1x C2y C3z. So it would be like this much. If you operate it, it will be C1I plus C2j plus C3k. So this is the gradient of the operator u. Now here comes a concept of directional derivative. Okay, so if you now, suppose I wish to take this is a gradient of the function u. Now I can take directional derivative of the function How do I take it? There is a question. Directional derivative means if this is your function c1x, c2y plus c3z, and this is gradient of the function c1i plus c2j plus c3k. Now the directional derivative of this much. In a given direction, okay, you take the dot product. Suppose in the direction of I, in the direction of x, conventional x direction, you take the dot product of this. Now this gives you the directional derivative. If you take the dot product, you know it becomes c1. Okay, like that, because I dot j and I dot k are 0. So this is the dot product in a given direction. This gives you the directional derivative. It's a very important concept. Okay, so that idea I just shared with you. Now, to continue with our discussion a bit more, I just get back to the PPT again. You see the PPT. So you can see here that the concept of gradient operator is there. So therefore, what you witness here is that this is the directional derivative. You see, if you take the in a definite direction, in a particular direction, if you just take the dot product with the unit vector in the direction, that is called the directional derivative. Now, to progress in our discussion a bit more, what we can now discuss, you see, it is written here, describing the change. What is directional derivative does? It talks about the change in a specific direction only. That is the job of the directional derivative. Now you see how it is showing the change. You please experience how the change is taking place. Okay, how the change is taking place. Okay, there is a u is the surface. Suppose u is the equation of the surface. So in a given gradient is giving you the change in the or the flow, the how the slope of the curve may be. In a definite direction, that slope is given by the directional derivative. Now divergence of a vector is called the flow of the vector. Now flow may be inward, flow may be outward. If the divergence is 0, there is no flow. And if divergence is greater than 0, the flow is going out. And if divergence is less than 0, flow is coming in. Suppose I have got a positive charge. If I only have the positive charge, electric lines of force are going out. So it is the divergence is greater than 0. For the negative charge, if you just separate it out, suppose there it is flows, the electric lines of forces are coming in. So flow is negative here. Okay, divergence is negative. But if you consider together both positive and negative charge, or suppose two poles are there, magnetic pole, north pole and south pole. Particularly in magnetism, whatever be the lines of force comes out from north pole, that ends out at the south pole. So finally, except between two poles, from north to south there is a flow. From south, okay, so north there is outward flow, and south at the south there is inward flow. But whatever be the line of force coming out from the north, that is getting inside south. So outside so basically there is no net outward flow. So divergence is 0 for the magnetic field. Okay, you can see this is a in case of charges. Okay, divergence is there. Divergence means flow of a vector. Okay, you look at the left hand side animation, it's a beautiful animation. It's a flow is there. Okay, how it is flowing, that picture you can clearly see. Okay, there is a flow of the vector. Okay, you can see the flow of the vector. There is a definite flow of the vector. Okay, You can see there divergence of A is there. So that is a you see there is another example. If you have got a vector ax, y, z is a vector function, its divergence is, you can see there, del a1 del x. Suppose A is like this much. Look at the example, it is very clear and extremely wonderfully presented. If A is a vector a1 I cap, a2 j cap, a3 k cap, its divergence means I1 j 1 kk1, so it is del a1 del x, okay, plus del a2 del y plus del a3 del z, and you can also take the, okay, that is the divergence of the vector. Okay, so that is the divergence of the vector. You can see it is the dot product of the two vectors. So if a is suppose xi, then what, it will be only 1 because only del x is there. If a is xi plus yj plus zk, I don't have to tell you, write it, you can understand. Then derivative of x is 1, derivative of y is 1, derivative of j is 1, ii1, jj1, kk1, so your result will be 3. Similarly, 1 by r cube r it is 0, 1 by rc it is that much. Okay. So now another beautiful idea is there. Okay. Suppose I've got two divergence operator acting. You please see here. You see divergence of gradient of a vector u. Gradient of a vector, gradient of a scalar u. Gradient of a scalar is given there. That is del u del x I cap, del u del y j cap, del u del z k cap. Now, if you take the dot product means ii will be 1, ij will be, kk will be 1, jj will be 1. So it will be like d2u dx2, dt plus d2u dy2 plus d2u dz2. So that d2x, d2u, d2 dx2, d2y dy2, d2 dz2, that is now called a new operator called Laplacian operator, del square operator. Okay, that is called Laplacian operator. And del square u equal to non-zero is called Poisson's equation. If u is the electric for potential, del square is u equal to 0 is called Laplace's equation. Del square is called Laplacian operator or Nabla operator. Okay. Suppose x square plus y square plus z square. If you take del square, so you get 2, 2, 2, it gets 6. The u is x square, y square, x, y square, z cube. So if you do del square, you can understand what would happen. Del square means first, okay, it will be like this much. 2x z cube plus, you can see it will be double derivative with respect to x will make 0. Double derivative with respect to y give you 2xy z cube. Y is 1. And double derivative with respect to z is that it will give you 3 into 2, 6, z square, z will be there, xy square. And 1 by r is 0. You can understand these things are easy. Now curl is another vector calculus operation. Curl takes care of the rotation of a vector, just like divergence was taking care of the flow of a vector. The physical meaning of curl of a vector is basically the rotation or the vorticity of the vector, as you can see here. Suppose I have got a velocity vector, and if suppose a fluid is flowing in the reverse also, if it flows, there is always some sort of vorticity. Few days back, there was a big storm called Amphan. Okay, there was a lot of vorticity, Ghurniঝড়. Okay, cyclonic speed. That's a cyclonic storm. So what is a cyclone? The velocity vector of the cyclonic storm was actually rotating. So that's why it's a cyclone. If the water flows also, the velocity vector of the water sometimes becomes rotating, particularly in the rivers it happens. Okay. Popularly they are called ghurnis, okay, like that. So that take care of the rotation of a vector, popular vector is called the is calculated through curl. You can see there. Suppose I have got any vector f at a point p, curl of f is it's a vector quantity, and direction is perpendicular to the plane of the vector. Okay, you can see there, that is another vector. It is, you see, you can see it is animated. It is shown there that rotation is being taken care of. Okay, it is taking care of that rotation. Now these are some more beautiful pictures. You see You look at the cyclonic storm there, okay? The storm is coming, okay? You see, it takes some time to see how it is changing, okay? You see the velocity is changing, okay? You see velocity is changing. Look at the picture, it is hitting India, okay? It's in the sea. The storm is coming, its velocity vector is changing, and our velocity vector is rotating. So here there is a rotation of the vector. So we say curl of the vector will be non-zero. If non-zero curl means it is a rotational vector. Irrotational, sorry, curl of f is here is curl of f here is okay. You can see there the velocity vector is always changing. Okay, it is rotating. Curl of the vector 0 means no rotation, and curl of the vector non-zero means there is some rotation. Now, how to take curl? You have to resolve determinant. I think you have learned it from mathematics classes. I, j, k, del x, del y, del z is taking coming from the gradient, and a x, a y, a z is coming from the vector a. So, if you resolve the determinants, I is taken. So, it is del z, del y, del ay, del z, I plus for j, you can see j, you can take it out. It will be del az, del x, del ay, del z, z plus for del ay, del x of ay, del y of ax. And you can put the value and calculate it. For example, your vector is say yi plus xj minus yi plus xj. So you can calculate it, okay? So minus yi means if you do it for the first case, you'll be getting there minus, you see del y of I, okay? If you put it there, I will be 1 there, and del ly is basically 1. So, but del l, if you put the, or that is this z is there, z is nothing, okay? Az is there, x, you see, if you look at the a here, ax is 0, ay is minus y, and az is basically here. You look at the expression of a. Shall I do it? I show you directly there. Suppose this case, if I show you directly, suppose I wish to take the my a vector is minus yi plus xa. So basically it is 0k. So I now wish to take the curl of the vector. So how do I calculate? Let me show you again. Please see here. So if you take the curl ijk minus y plus x0, oh, sorry, I'm making too many mistakes today. I'll show you separately, okay? A is minus yi plus xj plus 0k. Curl of A is ijk del x del y del z minus y x0. So if you do first I, del y of 0 is 0, del z of is 0, plus z, del z of minus y is 0, del x is 0, and del z of this is 0, this is 0, and the last term plus k del L x of x is 1 and del L is minus 1. So ultimately you get nothing. Okay, so basically it is curl is 0. Okay, so no rotation of the vector. So vector has got no rotation. So this is how you have to resolve a curl, which might have learned from your earlier courses. Okay. So now, if I finish, just get back to the PPT again. So these are the examples. How do you take the curls? So now some vector identities. Okay. Some vector identities are there. You can see them. Some vector identities are there. You can see divergence of curl of a vector is this much. Curl of gradient of a vector is 0. Curl of divergence of curl of a vector is 0. So next class we'll move towards vector integrals. So most of the things today you have got some prior knowledge. I only tried to tell you the physical meaning. So takeaway from the class is that we take gradient of a scalar, divergence and gradient, so divergence and curl of a vector. Gradient means change of the scalar in a definite direction. If you wish to take the change, you have to take directional derivative. The divergence means flow of a vector. Okay, the flow may be inward, flow may be outward. Okay, and curl means rotation of the vector. Okay, so these are all about the vector in differentiation part. Vector integration is another important issue. We'll discuss in the next video lecture.